Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi Herman and Corin. I'd love to chat today about a very relevant topic for those who are into building computers or working with computers, and that is static electricity. I think I asked you in a previous episode what would be your top recommendation for I want to set up a proper workbench. Not that we really have much space to put one, but anything's better than working crunched over on the ground, which is how I spent a large chunk of the past couple of days doing the computer stuff. And you mentioned an ESD mat as a fundamental thing. And it's interesting because I've read very different things about static electricity. On the one hand, you've people saying that static is the silent killer of computers, it's cumulative, and you have to be incredibly careful, and etc. And if you're not if you're not being absolutely wearing a static bracelet and putting it on a mat, you're going to fry your parts. On the other hand, I've heard people saying that that's garbage, and just touch metal at the start of your repair and you're pretty good. And when you go into repair places in general, like phone repair shops or whatever, you don't generally see people rigged up to anti-static mats, at least all the time. At least the ones that I've been into. You kind of peek back and you don't see, certainly haven't seen the bracelets actually being used, maybe in certain contexts, but not in general electronics repair. So Herman and Corin, that's question one. What is the lowdown on static? And one other question, sub-question, 1.1, is does it make a difference what kind of a place you're in? I ask that because I worked in the IoT company I mentioned before. One of our offices, they moved office, there was this crazy static problem. I never got to the bottom of it. Every time I would touch the door handle on the way out, I would get that little zap, to the point that it kind of became almost a phobia. And thankfully we moved to a new office and there was no more static electricity. Maybe it was because there was a lot of manufacturing going on. I've no idea, but I've never encountered anything like that before, where I'm getting zapped all the time for no reason. So I'm guessing there was something in that building that was very conducive to a buildup of static electricity. I think there's been some pretty comical static related stories. If I'm not mistaken, a jet bridge operator at Heathrow Airport had his trousers blown off by static discharge. So it's the voltage is more than you might expect. But for people who just have, your normal place, nothing weird happening, and just maybe occasionally doing stuff like seeding RAM or upgrading a CPU, small repairs to computers or upgrades to computers, do you need an ESD mat? Do you need one of those bracelet things? Or do you think that touching metal just before you start your repair, discharging the power switch is another tip I've seen. Taking out the power always, that should be pretty much enough. And finally, second question, anti-static bags for storing electronic components cold. For example, in the old computer, I managed to salvage the GPU, and I haven't been able to find, unfortunately, an anti-static bag that's up to size. How risky is it to store components like that for even a week? And why is it that literally every electronic that you get with exposed parts needs to be stored in one of those? And buying them, is it kind of one of those things that an anti-static bag is an anti-static bag, or do you need to look for something to get quality stuff if you're protecting valuable electronics from static electricity? Over to you, Herman and Corin.
Hey everyone, welcome back to My Weird Prompts. I am Corin, and I am sitting here in our living room in Jerusalem with my brother. It is a beautiful, crisp evening here on February 19th, 2026, and we are surrounded by a few half-finished projects and a lot of coffee mugs.
Herman Poppleberry at your service. It is good to be here, Corin. I have actually been looking forward to this specific discussion because it is one of those topics where everyone has an opinion, but the science is often buried under a lot of myth, legend, and frankly, a lot of survivor bias from people who have just been lucky.
It really is. Today's prompt comes from Daniel, and it is all about static electricity, especially in the context of building and repairing computers. Daniel mentioned that we recommended an electrostatic discharge mat in a previous episode, and he is curious about the actual risk. Is it really a silent killer of hardware, or is it just something that big tool companies use to sell us more gear? He also wants to know about the environment, the touch the metal trick, and the real deal with anti-static bags.
That is the $1,000,000 question, right? Or maybe the $1,500 graphics card question, given how prices have been lately. It is funny because static electricity is something we all deal with every day. You walk across a carpet, you touch a door handle, and zap! It is a tiny annoyance to us, but for a microchip, that same zap is like a lightning bolt hitting a skyscraper.
I love that analogy, but let us put some numbers to it. When we feel a spark, how much voltage are we actually talking about?
That is the key to the whole silent killer thing. To actually feel a static shock, the discharge has to be at least 3,000 to 4,000 volts. If you see a blue spark in a dark room, you are looking at closer to 5,000 or even 10,000 volts. Now, compare that to a modern processor. The internal traces on a cutting-edge chip are measured in nanometers, and the insulating layers. The gate oxides are only a few atoms thick. Those components can be terminally damaged by as little as 10 to 30 volts.
Wait, 10 volts? So you're saying I could destroy a component with a charge that is 100 times smaller than what I can even feel?
Exactly. That is why it is called a silent killer. You do not feel the zap, you do not see a spark, and you do not hear a pop. You just touch the RAM stick, and silently, microscopically, you have punched a hole through the silicon.
That is terrifying for a builder. Daniel noted that some people say you need the full kit. The mats, the wristbands, the grounded shoes, while others say just touch the metal case of your computer before you start, and you will be fine. And he also pointed out that many professional repair shops do not seem to use these tools consistently. So, Herman, what is the ground truth here?
The ground truth, pun intended I assume, is that static electricity or electrostatic discharge, which we call ESD, is a real phenomenon that can and does destroy electronics. However, the way it destroys them is not always what people expect. It is not always a puff of smoke and a dead component.
Okay, so let us break that down. When people think of a computer part dying, they think of the computer not turning on. But you are saying it is more subtle.
Right. There are two main types of damage from ESD. There is catastrophic failure, which is what most people imagine. You zap the chip, the internal circuitry melts or ruptures, and the part is dead instantly. You put it in, nothing happens. But the far more common and insidious type is called a latent defect. This is when an ESD event weakens the internal structure of a component without killing it outright.
So it is like a structural crack in a bridge?
Precisely. The bridge is still standing. Cars can drive over it. But the next time there is a bit of stress, maybe a heat wave or a heavy truck, that crack expands and the bridge collapses. In a computer chip, a latent defect might mean your system is perfectly stable for 6 months, and then suddenly you start getting blue screens of death or weird memory errors. You would never trace it back to that time you touched the motherboard while wearing wool socks 6 months ago, but that was the root cause. This is actually a huge problem in the industry because it leads to what we call no fault found returns, where a part works in the testing lab but fails intermittently for the user.
That makes a lot of sense. It explains why some people say I have never used a strap and my PCs are fine. They might actually have damaged them, but the failure happens much later or it just manifests as a random crash. They blame on Windows.
Exactly. It is a game of probability. You might get away with it 99 times out of 100, but that 100th time is your expensive GPU.
So let us talk about the environment. Daniel asked if the environment makes a difference. You mentioned humidity earlier. How big of a factor is that?
It is massive. Humidity is essentially nature's anti-static spray. When the relative humidity is high, say above 50%, a thin microscopic layer of moisture settles on everything. Water is conductive, so that layer allows static charges to bleed off into the air or across surfaces before they can build up to dangerous levels. But in a dry environment like Jerusalem in the winter when the heaters are on, or a high altitude office in Denver, the air is an insulator. Charges just sit on your body building up and up as you move.
So, if you are in a humid place like Florida, you are safer than someone in a dry place like Arizona.
Much safer, but not immune. Even in high humidity, you can still generate a charge through the triboelectric effect. That is just a fancy way of saying friction. When two different materials rub together and then separate, electrons are stripped from one and deposited on the other. Your cotton shirt rubbing against a plastic chair, your rubber-soled shoes on a nylon carpet, these are all charging you up like a battery.
Daniel specifically asked about the touch the metal case method. I have heard this advice for 20 years. Leave the power supply plugged into the wall but turned off, and then touch the metal case of the computer periodically to ground yourself. Does that actually work?
It is what I would call a low-confidence solution. Here is the physics. To prevent a discharge, you want yourself and the component you are touching to be at the same electrical potential. If you touch the metal case of a grounded computer, you are equalizing your potential with the ground. That is good. But the moment you move, or shift in your chair, or shuffle your feet, you are generating new static electricity.
Right, because of that triboelectric effect you mentioned.
Exactly. You can build up hundreds of volts just by reaching for a screwdriver. So if you touch the case, then move your arm to pick up a stick of RAM, you might have already built up a new charge by the time your fingers hit those gold pins. A wrist strap prevents this because it provides a constant high-resistance path to ground. It keeps your potential at zero at all times. It is the difference between manually bailing water out of a leaking boat and having a constant drain plug at the bottom.
That is a great way to put it. What about the power switch trick? Daniel mentioned discharging the power switch.
That is a different safety protocol entirely. When you unplug a computer, the capacitors in the power supply can hold a significant charge for several minutes. Pressing the power button while it is unplugged attempts to boot the system, which quickly drains that stored energy. It is a great habit to prevent you from getting a nasty shock from the PSU or accidentally shorting something while you are working, but it does absolutely nothing for static electricity. Static is about the charge on your body, not the charge in the capacitors.
Okay, so we have established that the risk is real, especially for latent damage. Now, Daniel had a very specific question about storage. He has a graphics card that he needs to store for a short period, and he cannot find an anti-static bag that fits. How risky is it to just put it in a cardboard box or on a shelf for a week?
This is where we need to talk about the different types of anti-static materials, because they are definitely not all the same. If you look at the bags that components come in, you usually see two main types. There are the semi-transparent pink or blue ones, and then there are the shiny silver metallic looking ones.
I have always wondered why they are different colors. Is it just branding?
Not at all. The pink or blue bags are what we call anti-static or dissipative bags. They are usually made of polyethylene treated with a chemical anti-stat. This chemical prevents the bag itself from generating a static charge when it rubs against other things. But, and this is the part people miss, they do not protect the contents from outside static. If you have a motherboard in a pink bag and you touch the outside of the bag with a charged finger, that charge can go right through the plastic and zap the board.
Wait, really? So the pink bags are only half the battle?
They are barely half. They are basically just non-charging bags. They are fine for non-sensitive parts or for use inside an already protected environment. The silver ones, however, are called shielding bags. They have a very thin layer of metal, usually aluminum, sandwiched between layers of plastic. This creates what we call a Faraday cage. Any static charge that hits the outside of the bag is conducted around the exterior and never reaches the component inside.
So for long-term storage or shipping, you absolutely want the silver ones.
100%. Now, for Daniel's situation, storing a GPU for a week without a bag, is it a death sentence? Probably not, if he is careful. Cardboard is actually a decent material because it is slightly dissipative. It does not hold a charge as well as plastic does. The real danger is not the box itself, but the act of picking the card up. If he puts it in a cardboard box, he should make sure it is not sliding around, because that friction can generate a charge. The biggest risk is that he walks across the room, picks up the card with a charge on his body, and zaps the interface pins.
So if he does not have a bag, what is the best move? Should he wrap it in something else? I have seen people use aluminum foil, but that feels like it could cause other problems.
Aluminum foil is a controversial one. It does create a Faraday cage, which is good, but it is also highly conductive. If there is a small CMOS battery on the board or some residual charge in a capacitor, the foil could short something out and cause physical damage. I generally advise against it unless you are absolutely sure the board is completely discharged. Honestly, if I were Daniel, I would just go to a local computer shop and ask if they have any spare bags. They usually have piles of them from builds they have done and will give them away for free.
That is a great tip. Most of those shops just throw them away. Now, let us talk about the workbench itself. Daniel asked about the environment and the table surface. If I am working on a wooden table versus a metal table, or on a carpet versus a tile floor.
Environment is huge. Carpet is the enemy. If you are working on a computer while standing on a carpet, you are basically a walking Van de Graaff generator. Every tiny movement of your feet is pumping thousands of volts into your body. Tile or wood floors are much better because they do not generate as much charge, and they are slightly more conductive, allowing some charge to bleed off.
And the table surface.
Wood is okay because it is not very triboelectric. But the problem with a plain wooden table is that it is an insulator. If you put a motherboard down on it and the motherboard has a charge, that charge has nowhere to go. An ESD mat is specially designed to be dissipative. It is not a perfect insulator, but it is not a perfect conductor either. It has a very high resistance, usually around 10 to the power of 6 to 10 to the power of 9 ohms, that allows static to bleed off slowly and safely to the ground.
Slow and safe is the key word there. You do not want a sudden spark.
Exactly. If you just touched a grounded metal wire directly, the discharge would be instantaneous and high current, which is what causes the damage. The ESD mat and the wrist strap have a 1 megohm resistor built into them. That resistor limits the current so the charge drains away over a fraction of a second instead of all at once. It is the difference between draining a water tank with a small hose versus popping it with a needle.
That is a brilliant way to explain the resistor. I think a lot of people see that wire and think it is just a plain copper cord, but that resistor is actually a safety feature for both the electronics and the human.
Right, because if you were wearing a plain copper wire on your wrist and you accidentally touched a live power line, you would be the best path to ground, and that would be the end of you. The 1 megohm resistor is high enough to protect you from electrocution at standard household voltages, but low enough to let static electricity, which is high voltage but very low total energy, escape easily.
So, looking at the big picture, if someone is just doing a small repair, like Daniel mentioned, upgrading RAM or a CPU, is it worth the hassle of the mat and the strap, or can they get away with the touch the case method?
I will say this, I have built hundreds of computers. In the early days I was reckless. I worked on carpets, I did not use straps, and most of those machines worked fine. But as I learned more about latent defects and as components became more densely packed and sensitive, I changed my tune. Modern CPUs have billions of transistors packed into an area the size of a fingernail. The insulating layers between those transistors are only a few atoms thick. It does not take much to punch a hole through that.
So the technology is actually getting more sensitive over time?
In some ways, yes. Manufacturers have gotten better at building in protection diodes on the input pins, which act like tiny lightning rods to shunt ESD away from the core logic. But the fundamental physics of how small these traces are makes them inherently vulnerable. My advice is this. If you are handling a $500 graphics card or a $400 CPU, why would you not spend $15 on a wrist strap and a mat? It is the cheapest insurance policy you will ever buy.
It is about peace of mind. Even if the risk is only, say, a 5% chance of causing a latent defect, that is a 5% chance I do not want to take with my expensive hardware.
Exactly. And once you have the setup, it takes 2 seconds to clip the strap to the case. It is not a major workflow disruption. Now, Daniel also asked about the quality of anti-static bags. Are they all the same? For the most part, yes, if they are from a reputable manufacturer. But you have to be careful with reused bags. Every time you fold or crinkle a shielding bag, you are creating tiny fractures in that microscopic metal layer. Over time, those fractures can break the Faraday cage and the bag loses its effectiveness. If a bag looks like it has been crumpled up into a ball and smoothed out, it is probably not providing much shielding anymore.
That is interesting. I never thought about the physical wear and tear on the bag. It looks like plastic, but it is really a precision-engineered piece of equipment.
It really is. And another thing people do that drives me crazy is putting the component on top of the bag while they work.
Wait, I do that. I thought that was the whole point, to have a safe surface to lay the motherboard on. Why is that bad?
Because the outside of many shielding bags is not dissipative. It is just a regular plastic layer, only the inside is treated to be anti-static. So, by putting your motherboard on top of the bag, you might actually be putting it on a surface that can hold a static charge. It is much safer to just put it on a clean wooden table or, better yet, the ESD mat.
Wow, I've been doing that for years thinking I was being extra safe. This is exactly why we do this show. You think you know the best practices, and then the physics tells you otherwise.
It is a very common mistake. Even some professional YouTubers do it. But if you look at the specs for those bags, they are designed to protect what is inside, not what is on top.
So let us talk about the really weird side of static. Daniel mentioned that story from Heathrow Airport, where a jet bridge operator supposedly had his trousers blown off by a static discharge. Is that even possible?
I remember that story. It sounds like an urban legend, but there is a grain of truth in the physics. Static electricity can reach incredibly high voltages. We are talking 30,000 volts or more just from walking across a floor. Now, the current is very low, which is why it usually does not kill us. But if you have a massive buildup of charge on a large object, like a jet bridge or a fuel truck, and it discharges through a small point, it can cause a rapid expansion of air, effectively a tiny explosion.
Like a miniature bolt of lightning.
Exactly. Lightning is just static electricity on a planetary scale. If that discharge happened near something flammable, like fuel vapors, or if the mechanical force was just right, it could certainly cause some dramatic results. I do not know if it would literally blow someone's clothes off without also causing serious burns, but I would not want to be standing there when it happened.
It really puts into perspective how much energy we are talking about. Even if it is not enough to blow your pants off, it is more than enough to melt a trace on a silicon wafer that is measured in nanometers.
Absolutely. And that brings us back to the repair shops. Daniel asked why they seem so casual about it. One thing to consider is that professional repair environments are often designed to be ESD safe from the ground up. They might have conductive floor wax. They might have ionizers blowing across the workbench to neutralize static in the air, and the technicians might be wearing shoes with conductive strips or heel grounders.
So they are grounded, but they are grounded through their feet instead of their wrists.
Exactly. It is a more expensive way to do it, but it is much more convenient for the technicians. So when you see them working without a strap, they are likely still protected by the floor and their footwear. If you are at home on your carpet in your rubber sneakers, you do not have those hidden protections.
That is a crucial distinction. We cannot copy the behavior of a pro without having the same infrastructure they have. So, for Daniel and our other listeners, the takeaway seems to be, take it seriously, buy the basic gear, and do not trust the touch the metal trick as a total solution.
Right, and if you are storing parts, get those silver shielding bags. They are cheap, they work, and they protect against more than just you touching the part. They protect against anything that might happen near the bag, like someone else walking by with a high charge.
I think we have covered the bases here. It is one of those topics that feels like it might be overkill until you lose a piece of hardware you really cared about. Then you realize that $15 for a mat was a bargain.
It is all about risk management. We are not saying your computer will definitely explode if you do not use a strap. We are saying the risk is non-zero, and the cost of mitigation is so low that it is the logical choice for anyone who values their time and money.
Well said, Herman. I think we should probably wrap this one up soon, but before we go, I want to make sure we give some practical advice for people who are maybe in the middle of a build right now and do not have a mat. What is the absolute best thing they can do with just common household items?
Okay, if you are in a pinch and you have to work right now, first, work on a hard floor, not a carpet. Kitchen or bathroom tile is usually better than a bedroom or living room. Second, work on a wooden or metal table. Avoid plastic folding tables if you can, as they are very static prone. Third, stay barefoot. Your skin has enough moisture to help bleed off some charge to the floor, whereas socks are static machines. Fourth, Keep the computer plugged into the wall but with the power supply switch in the off position. This keeps the case grounded to the house wiring. And finally, touch that metal case every single time before you reach for a component. Do not move your feet between touching the case and touching the part.
That is a great emergency protocol. It is not as good as a strap, but it is a lot better than nothing.
Exactly. It is all about reducing the probability of that one unlucky zap. And one more thing. Avoid wearing wool or synthetic fabrics like polyester while you work. Cotton is much more neutral and less likely to build up a charge.
Good tip. I will put away the Christmas sweater before I open up my PC. Well, I think that is a wrap on episode 698. This has been a fascinating deep dive into something that literally surrounds us all the time.
It really does. Static is one of those invisible forces that we just take for granted until it ruins our day. I enjoyed digging into the physics of it with you, Corn.
Me too. And hey, to all our listeners, if you've been enjoying my weird prompts and you've been with us for a while, we would really appreciate it if you could leave us a review on your podcast app or on Spotify. It genuinely helps new people find the show and keeps us going.
It really does. We love hearing from you all, and we love the technical questions like Daniel's.
You can find us at myweirdprompts.com. We have an RSS feed there for subscribers and a contact form if you want to get in touch. You can also reach us directly at show@myweirdprompts.com. We are available on Spotify, Apple Podcasts, and pretty much everywhere else you get your audio fix.
Thanks to Daniel for the prompt today. It was a good one.
Definitely. All right, everyone. Thanks for listening. We'll be back soon with another episode.
Until next time, stay grounded.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.